We want to be on time, so 9:30 we are punctually starting the next session. And with that, let me welcome Bala, who's a principal architect at Google Cloud. He's been with us, working with us on this transformation journey to Google Cloud for nearly 5 years, over 4 years now. And we'll hold a talk together with Bala on LLMs, the deep dives into LLMs, the future of LLMs, and text to action, what we can do with those models and what can they bring to the business. With that, the floor is yours.
Could you all hear me? Okay, thank you, Marek. So what I'm going to do is, before we dive deeper into all the technical aspects of the LLM, I wanted to start off with, where is this LLM going and when it started, and what does the journey look like, and will we ever get to AGI, right? So what you see here is from Google Trends. So if you go to trends.google.com and type in these two words, LLM and large language models, right? So you would see on the timeline, right? There was little interest with large language models, but there was still some going on before 2022, okay? So I know we all talk about AI, we are in the AI world, but AI is not something new. It has existed for over 4 to 5 decades, right? It existed in the colleges. So we started with, predicting just four words, okay? So we would say, like, you type in a word, it will guess what the next word is, right? So we started with 4 words, and it used a lot of compute too.
And then the first one was in the 80s, right? Jeff Hinton. They did that on a small little compute, but they knew at that time that this can actually lead to much better output many years in the future. It was already in the 80s.
Absolutely, absolutely, right? And then they all got excited, they saw the potential, and then they said, okay, can we do 20 words, right? And then talk neural networks, and then we talked about RNNs. If there are ML engineers here, everyone was very excited about RNN. It could do 20 words. And then we said, okay, RNNs with LSTM, right? That would do 200 words, but you would really need so much compute to do that. And then in 2017, Google published a paper called Attention is All You Need. And of course, Marek is going to share something about attention is all you need. And he's going to talk about that transformer architecture. Now that kicked off a whole slew of things, right? People figured out now the input can be thousands of words, right? And then we saw 2022, we saw the June of 2022, GPT 3.0 came out, right? And then you would see the blue line and the red line. So the blue line is about people searching for large language models, right? Now, the LLM word became a more common word. And now you would see like people are searching more for LLMs rather than large language models, which tells you that, something is becoming commercialized, commoditized, and then it's becoming a common word that we use every day, okay? So if you look at what is happening to all the models, you're going to see a lot of models come out. Some of the big players that you would see is your favorite, Meta and OpenAI and Google, and you're going to see a lot of these companies mushrooming. Now we are in the place where internet was in 2000s, right? So this is the AI boom, and we are seeing something can be real, and you're going to see people invest more and more in this technology. So what do we see in the industry, right? Now, there are 4 major things that are happening, okay? The context window, we talked about, like, starting with 4 words, talking with thousands. Now people are talking in millions, right? So I can do 1 million with Gemini, and then we are keeping on increasing the context window. So what can you give to a LLM as input? That is increasing. That context window is increasing, which means that I can give a whole book. I can give the entire data set that I have in my enterprise. I can do a lot more. I can do video. I can do audio, right? So not only that, the input context as well as the output context. So if you looked at all the LLMs in the beginning, it would restrict you to like 1024 words that you could get back, the tokens that you would get back, right? Now that is also increasing. So you're going to see the market responding to this, and every AI vendor out there is going to increase the context, the input context and the output context. So industry, watch for all the LLMs that are coming out. This is what I showed you as a trend was just a few. More is coming, right? The second big thing that is happening is we are all going multimodal. So what does that really mean, right? So humans can see, can understand what they see, and then they can process it and tell a story, and then they can do inferences on the top of it, right? What if I had text, the audio, the video, the images, and then I can feed all this as input to a model and come out with beautiful, video and text and action, understanding the intent, and doing something based on the intent, right? So the multimodal is picking up. So it has existed in different ways. Some people had speech, some people had video, some people had image processing with the AI. Now all this is combined, and Gemini was built ground up as a multimodal model. And then the next thing, the third thing that is happening is agents. Okay, so we started with just the model, and then we went a little bit further and said, the model is hallucinating. What do I do for that? And then we came out with beautiful RAG systems, right? And then we went a little bit ahead and said, how can I add reasoning and how can I add orchestration to it? And now putting it all together, we have an agent. So agent is an application where you give an input, it will understand, and it can reason, and it will invoke the appropriate tool, and then it'll take an action based on the intent, right? Now, having agents, you're going to see a variety of things happening with agents. So you're going to see the agent pathway to where we want to get to is growing pretty fast. And then you have text to action, which is another interesting thing that is happening. Most of you would have used Siri, the assistants, Google Assistant, right? So anything that you use there, right? Can I feed in text and ask it to take an action? Now that is a growing field. A lot of things are happening in that space, right? And finally, we have AGI. And hopefully, in my life, I hope I would see AGI, right? Maybe, maybe another 10 years. Who knows, right? Now we talked about the model, starting with the model, right? So the model was fun. So it was released 2022 based on the transformer architecture, and everybody got excited, and a lot of humans got in and gave feedback, and then the model kept on improving. But what happened was it was giving you a lot of giving you a lot of things that were not true. It was not sensitive. So it's kind of hallucinating, right? So how do I fix the hallucination problem? So what if I ground it, right? If I give it the context, if I give it the data that it needs, then I would stop it from hallucinating. So I kind of grounded, and that's where RAGs came along. Retrieval augmented generation, right? This is basically saying I have information. I'm going to, any question the user asks, I'm going to go back to my database. I'm going to pick something and give you the right context, and I'm going to ground you on that context. And now you have the information. Go and figure out what you will tell me with this context, right? And then we said, okay, what is the next thing that needs to happen? Maybe I have to ground it with multiple systems. Maybe based on the intent, I have to reach out to multiple tools and bring out the right information. And that's where agents came in, okay? And agents basically gave you the ability to orchestrate, to reason, to pick the right tool, and to execute, create and execute functions that would give you the right answers. Now, we are going to talk about a lot of agents, and we are going to talk about all the things that I was talking about from the start, right? When it comes to agents, you're going to see modality-based agents or use case-based agents. So everyone out there in this industry is going to come out with some kind of a specialized agent and they're going to, either be a, LLM model, or it's going to be a VLM model or VLA model, or you're going to see use case based, where it's a particular industry. Might it be a manufacturing industry? Might it be gaming industry? Or might it be customer support, cybersecurity, software development, whatnot, right? It is limitless. And if you look at the way the agents interact, today you hear a lot about these chatbots. You hear a lot about conversational AI. Can I have a dialogue with someone on the other end, and that someone is AI, that someone is an LLM, right? So kind of maturing, because we had chatbots even before LLMs. It was really hard to do, but we are now at a point where we can have very mature conversation with an LLM. And then we have workflow agents. This is where there is no human interaction, right? So there is an event that is happening, and then you kind of pick up an agent, and then you ask the agent to do something, and based on that trigger, it'll go and perform an action. Now, what is the next thing, right? So we have agents, specialized agents, and all that. Now, what if, like humans, agents can all come together and work together and be collaborative? That's what you see on the left-hand side in this slide, right? So there's a big queue, then there's a lot of agents collaborating with each other to kind of do something for you, right? On the other hand, you can also think about a model where it's top-down supervisory. So there is one agent who kind of orchestrates and manages, and then there's a series of agents who do the task and kind of coordinate and give it back to the user, right? So agents and multi-agents is kind of the future roadmap. And you are going to see models keep on increasing the context window. And you are going to see more and more LLMs and AI in specific getting to AGI, right? That generic intelligence performing like a human hopefully will be a reality in our lives. With that, I'm going to pass it on to Marek. The next 3 days, whatever you heard in this little speech, you're going to deep dive into every one of those. With that, Marek.
Thank you, Bala. That was an amazing segue into what we are going to talk about now. So we are a group of hardcore developers here. So we don't just want to listen the slides about where this is going, but we want to see it in practice. So what I'm going to show you right now is how to actually build that type of agents. What can we do to instigate action from text? And how are the multiple other applications of that used in the industry right now? Just a sec. Okay, so let's start with a little trivia. Who won a Nobel Prize in physics this year? Does anyone know? Come on. Right. Hot, hot, hot. Yeah. So, that physicist is actually an AI godfather. He was titled an AI godfather because of the seminal work he did on backpropagation. That's the algorithm that actually makes the neural network, that adjusted the weights of the neural network so that it actually predicts the next word with high accuracy. So come on, you definitely know who he is. Yay! The prize goes to Tomek. Yay. So Geoffrey Hinton won the Nobel Prize in physics, even though this was an AI prize. He's 76 years old, born in London, UK, spent majority of his time in Canada at the University of Toronto. So who won the Nobel Prize in chemistry? Take a guess. You know, the first question probably was already hinting at something. Demis Hassabis, who the prize goes to over there. Demis Hassabis is actually a CEO of Google DeepMind. He built AlphaFold 2. That's a model that is able to predict the protein folding such that right now you don't have to actually spend countless hours, countless millions of dollars to do petri dish experiments. You can simply use your computer right now to predict that. So those are those advancements, and the fact that actually they became Nobel laureates goes to show the importance of AI in the modern world. This is groundbreaking. Those were phenomenal research papers that they came up with, and they arrived, their work was rewarded with probably the most scientific prize in the world.
I was just going to comment there, right? So the AlphaFold and AlphaFold 2 is an open source database. So about 2 million drug researchers use it today. So we store about 2 million protein structures in it. And they were awarded the Nobel Prize because the humanity would gain a lot from those models. Now the drug research can accelerate and expedite, and that's why they were chosen to receive the Nobel Prize.
So one last trivia question: what do they have in common, Jeff Hinton and Demis Hassabis? Google is not allowed to answer. Right. Actually, the prize should go to you, indeed. But the right question is actually they are both Googlers or ex-Googlers. So Jeff Hinton until last year was at Google, at the originally Google Brain, now DeepMind. Demis Hassabis leads actually Google Brain, Google DeepMind right now. Yeah. So it all started at Google, as you saw, with this seminal paper, "Attention is All You Need," and there's actually a Polish context as well. One of the authors of this paper was Łukasz Kaiser. He is still at Google. Many of those people from the list right now are ex-Googlers. Łukasz, I believe he still is. He's not only a researcher, but he actually shares his knowledge, does a lot of presentations and courses. You can watch his courses on Coursera.com as well. So again, like it all thanks to Google research. They invested millions and millions of dollars, billions actually of dollars, into making the AI work as it does right now. So let me very briefly walk you, that's super quick. I'm not going to go into the details of it, not to bore you. This is the most prevalent architecture of an LLM right now. The coder-only models, there are encoder-decoder models, but mostly right now the LLMs are the coder-only models. So you see actually you don't see it here, but between input and positional encoding, there's an embedding. You have to embed the text that you're converting from any input into a vector space. You add a positional encoding. Positional encoding is the order of which place in the sentence that particular word has. Then it goes to this masked multi-headed attention, which is this seminal paper that actually made it all work. Those are the relationships between the words in a sentence. Then there's a feed-forward network. That's a real neural network. That piece is a real neural network. And then you have the softmax layer where the LLM throws out the probabilities of the next word. And that's how actually the next word is predicted. The tool use, what is tool use? So, you collect information about Sabre recent stock price. That tool use will produce you a table like that. Then you say, add the predicted value column to the table. So, it's going to add one more column, use a factor of 2 to predict the value in the newly created column. And it's going to add that column to the result. Now let's organize this into a 2D plot. The x-axis is the date, y-axis is the values, previous close, open, bid, and ask. And this is it's going to plot it. So that's a tool use. That's text to action. So how does it do it? LLMs, they cannot immediately instigate any action. They just predict the next word. That's what they do. So how do we make them actually instigate this action? So if it wasn't connected to anything, just like in this slide, the LLM would say, I can't provide real-time information when you asked it what is the temperature in New York. But if it was able to identify the function to call and extract the data from the input, so New York in this case, call an external service, it would tell you it's 50 Fahrenheit, right? So I'm going to show you how you can make it work that way. We'll walk from a single function call through parallel function calls, nested function calls, multiple functions calls, and such. And we will finish with web browsing. How you yourself at home can do web browsing with the usage of an open source LLM that's right now is even better than commercially available LLMs that are more generic. So there are various function calling LLMs. I just touched upon this, that you can use a commercially available model, which is Gemini, Mistral, any of OpenAI models, or you can use a special purpose LLM that was highly trained to focus on a simple, small set of tasks. In this case, identifying and generating a function to call. So there is a company called NexusFlow. They came up with this open source model Raven 13b. Google it, you'll find a GitHub repository with that solution. It's tuned to provide function calling services. So it was trained just from the input, from the query, to provide you exactly the function to be called in your code, or an API service, an API function, so a method in the API to be called. It will always return a function. It does not say, like, you ask ChatGPT or Gemini or any of those tools, it will say something when you ask it. This one only returns a function. That's the primary goal of this LLM. You can run it locally. You can run it on your own laptop. It's nearly free because you don't have to pay for it, since you're running it on your local. And it performs better than currently available commercial models. So what's the difference between function calling, tool use, what that really means? So function calling is just a name given to LLM capability. When you go through Gemini spec, when you go through GPT-4o spec, any of those models, you will see that they have the capability of function calling. Initially, a year ago, they came out with single function calling, and they've been adding more to the picture. Now, those are supporting parallel function calls, multiple function calls, nested function calls, which I'll briefly talk about in the next slides. And the tools are the actual functions to be called. So those are, in your code, you have multiple functions, you call them for a variety of reasons. That's actually what you can call a tool. So I'll have a couple of examples, real life examples. This is actually, a simple plot. So we want to plot some points. That's a function that plots what you see here. There is no LLM at all involved. There is a user query. Hey, can you plot y equals 10x, where x equals 1, 2, 3, or more for me? There's no LLM use in here. On the next slide, though, here's the prompt that will be passed to Raven. Raven is this model. So it's wrapped up in an F string in Python. So function, it defines the function. That's the function definition. There is description of this function, plots some points. So now the LLM, if this prompt is passed to it, will know what to do with what this function does. And there are also there is a user query that will be passed to this Raven model with this prompt, and the user query was, as you saw here, hey, can you plot a equals yada yada yada. So now what we are going to do is we are going to call this function call. So as a result of this function call, the Raven returned plot some points x 1, 2, 3, y 10, 20, 30. And then we executed this function call, and all of a sudden you got that plotted on the screen. So again, just a recap. So what happened here? When you have the name, what you're passing actually to the model in the prompt is the name of the tool. In this case, the name is actually the name of the function. Like in this example, get temperature, get temp. Information to be extracted, that's the variable that you're passing in the function. While user query is what you're asking. So LLM must be also trained to recognize this function call. And the description that you pass in this prompt is actually when to call this function. So you generally tell it, return a temperature given a city name. That's the description. And if you pass it to the external service, it will generally give you the exact details of the temperature. One important thing perhaps is that, once the Raven model gets it, it returns you the exact string that can be executed. So what are the variations of those function calls? Single call, you just saw a single call. Parallel calls, that means that we can execute in parallel even the same function or multiple other functions. There can be no call, because in some cases, if an LLM is not able to handle the question, it can default to no call, basically. Multiple functions, you can call multiple functions in a sequence, or you can call them in parallel. And nested functions. The nested functions are actually the coolest ones, because you can take the output of one function and use it as an input in the next function. And those type of function calling capabilities are used to build agents. Bala has spoken about agents and the future of where the AI is going. So agents are being built with usage of this type of capabilities. That's why it's so crucial to actually understand how this is done. It's not magic, it's just code. So parallel function calling example. So in here, what I'm going to do is I'm going to have a prompt. Hey, can you build me 2 clowns? The first clown should be red-faced with a blue nose and the mouth from 0 to 180 degrees. The mouth should be black. The second clown should have a blue face and a green nose and a red mouth that's 180 degrees to 360 degrees. So this prompt, I'm passing it to a function called buildRavenPrompt, and I'm passing it to a method drawClownFace with that particular prompt message. You can see when I print the Raven prompt that in the second red piece, the second red rectangle, that is what the prompt looks like. So you can think of it as if you actually copy pasted it into your LLM. That's exactly what's being passed to an LLM. There's a function signature. There's the function so-called docstring, so it's a description, and there's a user query. So when we pass it to this LLM in this red rectangle, you now see what this LLM produced. The LLM produced two functions, same functions, that's why we call it parallel function calling, both called drawClownFace, with respective parameters, variables passed into this function. Those parameters were extracted directly from this Raven message at the top. The message says the first clown should be red face with blue one, blue nose, so yada, yada, yada. So it extracted this data, and then you could execute this call directly. So when we executed this code, that's what you got. So now you have an LLM that's capable of producing something real. That's the action that the LLM is taking. So what is multiple function calling? So you saw single function call, you saw parallel function call, and now I'll show you the multiple function calls. So you can have multiple definitions of your function. The APIs we are building here, they have 10 plus endpoints, 10 plus or hundreds in some cases. You can pass it all in to that type of an LLM to call multiple functions as needed. So this will be an example of multiple function calling. And in this case, we are going to tell the LLM to draw a face and a tie. So as you can see here in the Raven prompt, the first rectangle, there's the buildRavenPrompt function calls two functions, drawClownFace and drawTie, and it's passing the Raven message. Again, the prompt looks like in the second rectangle. So there's a definition, the signature of the function, the docstring, and the user query. And since the message we passed was just draw a tie, you can see it in the first rectangle, hey, draw a tie. Even though we passed in two functions here, so drawClownFace as well as draw a tie, it understood that it just needs to execute just this one drawTie function. And it did, and it resulted in the LLM, the code actually. The LLM generated this drawTie, and the code of yours, your own code that you control, generated this tie. Okay, so now let's check if the same code, if we passed a different message, draw a clown and a tie, what would it do? So now, since we passed two actions in this prompt, it not only drew a tie, but it also had drawn a face of a clown, because we told it to draw a clown and a tie. So what is the significance of this docstring? Docstring is this, again, like here, the docstring is the part where you define the parameters, face color, so on and so forth. Why is it so important? So if we did not change anything, I will show you how it fails. So I'm saying here, draw me a sad one with green head, sad face with a green head. It draw a face, green head. However, I don't think it's sad. It's rather neutral, let's call it, or even happy, some may say. So why has it failed? In the doc string, you have the definition, the parameter definition, and it says mouth starting and ending angles in degrees of the mouth arc. Default is 200 to 340. It doesn't know. It does not know that it can, based on the definition of whether it's happy or sad, how to translate it into, angles. So to fix it, you just add controls the emotions of the clown. You just add this short information into the parameter definition, that this parameter controls the emotions of the clown, and all of a sudden, when you execute exactly the same code, now it understood that the clown's face should be sad. And that's the coolest part, the nested function calling, because with this, that's the future of agents. That's the future of our use of actions in LLMs, because now you can think of it as you have 300 external APIs to be executed upon. When you ask an LLM just one question, with this capability of LLMs, they can do it, because they will go get the data from one place, use it in the next call to the next function as variables, call another external function, take it again, use it in the third call, so on and so forth. So basically, it's as if you are doing your research. When you're doing your research, let's say you're writing a thesis, you go Google, you take the input from one data source, you process it, you use it as an input into the next query, into the next search, Google search, and so on and so forth. So agents will use it exactly in the same way as you do. So nested function calling example. So in here, we have, this is broke. Now the drawing part is broken down into drawing a separate head, separate eyes, separate nose, so on and so forth. And there's a collection function that draws clown face parts in here. So in this example, when you build a prompt, you're passing in those separate functions: draw head, draw eyes, draw nose, draw mouth. And you then execute, you nest these functions, draw head, draw eyes, draw nose, draw mouth, into a function that's called draw clown face parts. So we are nesting 4 functions into this one that's collecting all of them. And when we execute it from this one prompt, hey, draw me a clown with a red face, blue eyes, green nose, and a black mouth, open from 0 to 360 degrees, it actually draws this clown. So in short, this is just an example of one nesting, but you can think of it as, you can have hundreds of functions nested in one another. So now, since this was all in the code, it generated actually Python function that was executed in the Python environment. How do we call external APIs? You may think, okay, that's cool to do it locally, but let's try and grab some data externally, meaning let's take a call to an external API. In this example, we'll use Meteo API and the Joke API to show you how to do it. There's multiple OpenAI, there's multiple RESTful services available. There's an easy way actually in Python to generate an API client from from an open API specification. So just before we actually do a deep dive into external function calling, this should give you an idea what this API does. So this joke API, you pass it the category of a joke. In this case, the category is any. There are parameters like safe mode and two-part joke. And I'm printing the setup and delivery. So what's being returned from this JSON is then displayed to the user. And the joke is, my mother said, you won't amount to anything because you always procrastinate. And I said, oh, yes, you wait. So now let's take this and let's call this external API with an LLM. So the user query is, can you get me a joke for this December? And the Raven function, just like I showed you before, it's passing the definition of the function, the doc string, and the user query. And we are executing it directly. So when we execute this Raven function, it will go back to the function we created, this give joke function. It will call this external API, and then it will display it back to you, to the user. So why did Santa's helper see the doctors? Because he had low elf esteem. And now let's go into a bit more complex. So now let's generate an API client from actually YAML OpenAI spec. So with this tool, we can generate API client. So we just generate it very quickly. That's how easy it is to be done in Python. And you can see on this screen the prompt that we are going to pass to an LLM specifically. So there is get v1 forecast function that was fully generated by this API generation. And there is a doc string. The description of this function requires the latitude and longitude, set current weather to true to get the weather, set hourly and daily based on preference. So basically, this is what you take from API spec. There are some of the parameters that are required. The LLM needs to know it, so it fills it. And then when we pass it to the LLM, the second rectangle you see is the function get v1 forecast. It does have the latitude and longitude and current weather set to true. It was able to determine it from the user query that's at the top, that's called, hey, how is the current weather and wind speed in New York? So with the new, the longitude, all sorts of things, and then you call this function, and that's what it gets you. It gets you the JSON that's come from the OpenAI, Open Meteo API. So now you know how to call external services. What you will need to know is how to now extract some data from the data that was returned to you so that you can present it to the user. And here, function calling also comes in handy because you can use function calling to extract the named entities. So it used to be called named entity recognition in the AI space. Now you can do it easier with function calling. So in this example, the user text is Mari had a little lamb whose fleece was white as snow. And there's this function we called extract ownership info. And the info we want to extract is the person name and who owned object. So in this example, we were able to get that the owner of this lamb is Mary and the owned object is a lamb. And now let's do a bit more of a complex example. So here's a text with names and streets of the person, of the people that live in those streets. And with this piece of code, with Raven again, so that model that was specially trained to do function calling, we are able to get the list from that text, an extracted list of names and their respective streets, because the function that we use here, this address name pairs, was asking of the list and the corresponding addresses. So when we executed it, this is what we got. There is a more advanced way to do it. You can use data class Python decorator that defines those variables. If you do it, this example actually goes to show how you can take the input from someone's query. So you can think of building an agent that will ask you, what's your predicament, what's your challenge? You have a customer care agent chatbot, and this chatbot is asking you multiple questions along the way. And then when it grabs this data, it will need to put it in the database, store it in the database so that you can reuse it later. That example goes to show how you can do it. The reason is that there is a long text. There are two variables, name and address, and the result of this Raven prompt is the insert into database function to be called. When you execute this function, you can save this data into a database. So that's that is the last example, and I'll give you a summary of what we learned, and then we'll move on to the next. Yeah, go ahead, Bala.
No, I'm going to give a little bit context before you summarize. I want to give a Google context to this. Great way of showing all the methods that we could use. I'm sure
let's just do the web search, as the web search, is the last one. So in this example, the query is the prompt that you're passing to the model is, hey, can you tell me more about this R1 thing? R1 is this rabbit AI device. If you ask this LLM that question without enabling ability to call external web search, it would tell you, I'm sorry, but I don't have any information about the specific R1 thing. So what you can do, you can use an API that gets the search. So you pass in, that's the definition of do web search function, the respective API keys, all the things that you need to send in the payload. And when you do it, you pass this again, the prompt, the function calling prompt as shown on the previous example. You call this do web search function with exactly the same query, which is, what is this R1 thing? And there is a grounded response. And the grounded response says the Rabbit R1 is a personal assistant device developed by Rabbit Inc., yada, yada, yada. So when Bala was talking about groundedness, about RAG systems, this is how you can ground your LLMs in reality. This is how AI can know and access the world in a way that we access the world. Like we walk, we have eyes, we process information, so on and so forth. Those functions calling are at the forefront of the modern AI tools and modern AI products. Those are relatively simple concepts, but when they are joined and when they actually work together as a set of products, they look like magic. Those are the moments when you actually ask the LLM and it does multiple things one after another, and you simply think to yourself, how is this possible? So whenever you do this again, just mind this talk and mind that those are not really magical things. All of us here can really, really easily build those type of functionalities into our own products. And with that, Bala, over to you.
Yeah, sure. That is great. You covered a lot of content there. So I wanted to give some Google context here, right? So I think a lot of AI ML engineers are in this room. How many of you have used Vertex AI? Just raise your hand. Okay. So there's a lot more that have to use Vertex AI. So the first thing, you hear Marek talk about prompts. So from writing code, how to write objects, how to write a Java code, how to write C++ code, all he was talking about is prompts. So that is the first thing that you got to know. The world is changing where you are just going to ask someone to write the code, and it is going to write the code for you. You need to know what to ask. So what Google is doing in this space is we are coming up with power prompts and fix my prompt capabilities, where you could give a prompt and say, like, I don't know what to, how to exactly ask this. You put something in, and then it'll enhance it. Okay. So that is with the prompt. So software development from now on is going to be very, very different. And Santosh is going to talk about code assist in the next session, right? So keep that in mind, okay? So do you throw away all the software best practices that you have done so far? No. You're going to follow all that, but your mindset is going to change. Your mindset is going to change to such a way that you are going to ask the right question to the LLM so you could create any kind of pattern, any kind of code you want. So that is the first thing, right? Second thing, what Google is doing is Vertex AI is a single unified place where you could develop the model and all the way go up to deployment. So what do we really mean by that? So Marek talked about a lot of models. You can use any model you want. So we have a model garden within Vertex. So the model garden, we try to be as close as possible to the current versions of all the open source LLMs that exist. Might it be the Meta Llama, or might it be the OpenAI spec, or might it be all the models in Hugging Face, right? You would get it in the model garden. So what does that mean? When I say you get it in the model garden, you just with one click, you could deploy that model and use that model. So that is the power of using Vertex AI as a unified tool, okay? So start your journey there and start using it, right? Two things that you will use in Vertex AI. You will have the enterprise collab, okay? This is kind of a notebook, an enterprise notebook that can be shared, versioned. Multiple people can work on the same notebook, right? And then you have the workbench, Vertex Workbench, where you could do the end-to-end building, deploying, maintaining, monitoring, and whatnot, right? So the next thing that Marek was talking about, all the ways, the function calling, the parallel function calling, the web search, all those capabilities, we are trying to make it easier and easier for the consumption when it comes to all kinds of personas, whether you are a developer, whether you are a business person, whether you are doing the deep data engineering work, right? So the way we do that is we incorporate Gemini into all our products, number one. So you will have the assistance that you need in all these places. The second thing is we have an agent builder. So you don't have to do the hardcore work of building this application called the agent, right? So the agent builder will allow you to build the agent with the capabilities that Marek was talking about, okay? So with that, I'm going to give it back to Marek to summarize.
Yeah, so what we learned today is how to create prompts that allow LLMs to perform function calling. Used LLMs with multiple function calls, nested calls. We invoked web services as well using function calling. And most importantly, we extracted the data from the prompts as well as we did a web search. So that is a good sort of introduction to how you can build your own applications with capabilities of text to action. And with that, let me hand it over to Santosh to talk about agents. We will have a short break until 10:30. So we'll have 7 minutes. Perhaps, yeah, around perhaps questions, right. Sorry. Yeah, perhaps you have some questions. If you do, feel free to ask. Or feel free to come to us and we'll definitely. Oh, there's a question.
How we can reduce hallucination of LLM in nested function callings? Because LLMs often hallucinate and doesn't give correct answers.
So since people are actually, let's talk directly. So, okay, thank you.